Atomic spectra. Generally, atomic spectra is a fingerprint of an atom. Why you are calling it is a fingerprint of an atom? Different atoms are having the different energy levels. According to that energy levels, different atoms will release the different wavelength lights. That means the spectra of the different atoms are having the different wavelength lights. That's why by seeing the what is the type of the wavelength light is absorbed by the atom, we can find what is the type of the atom. That's why the atomic spectra is called fingerprint of an atom. And how we are getting the this atomic spectra? First you have to give the energy to the atom, the ground state atom, and when you are giving the energy to the ground state atom, the electrons present in the ground state will take that energy, and what is the type of the energy is absorbed, that will be again depends upon the energy difference. So for example, let us take it is the E1 and it is the E2, and when you come to this E1 and E2, they are having the some energy difference that will be equal to E2 minus E1. So that amount of the energy will be absorbed by electron. When this amount of energy is absorbed by electron, immediately what happens, the electron will promote to the this energy level from E1 to E2. If energy is absorbed by the atom is equal to the E3 minus E1. So what is the E3 minus E1? Let us take the this energy level is the E3 and this energy level is E1. The energy difference between these two equal to E3 minus E1. If the electron is absorbing the amount of energy equal to this E3 minus E1, then electron will promote to E3 level. So like that, when you are giving the energy, the ground state electron is absorbing the different wavelength lights and it will promote to the higher energy level. When the electron is present in the higher energy level, that is called excited state electron. And after that, when you are stopping this energy, after that the electron will comes back. The excited electron will be come back, and when it is coming back, what happens? The amount of energy will be released equal to energy difference. For example, if it is E2 minus E1, that amount of energy will be releases. According to that one, certain wavelength light is releasing, and this light will be fall onto the photographic plate and will get the spectra. So like that, if the electron is coming from E2 to E1, it will release one type of the wavelength light. If it is coming from the E3 to E1, it will release the another type of the wavelength light. Like that, the atom will release the different wavelength lights, and what it may be different, these different wavelength lights are emitted, that will be fall onto the photographic plate, and according to that one we will get the spectra. And next let us come to the hydrogen spectra. So how we are getting the hydrogen spectra? First you have to take the hydrogen gas into the electric discharge tube, and by using this electric energy, the hydrogen gas molecules will first convert into hydrogen atoms. After that, these hydrogen atoms will absorb some more electrical energy, and in that process the ground state electron will move into the excited state, and after that the excited electron will be comes into the ground state. When it is coming into the ground state, it will release the different wavelength lights, and these wavelength lights will be fall onto the photographic plate, and this photographic plate, what it may be lights present on this one, is called a hydrogen spectra. And when you come to this hydrogen spectra, it contains the total 5 different series lines. Those are called, one is Lyman series, Balmer series, Fashion series, Bracket series, Fund series. Total 5 different series are present in the hydrogen spectra: Lyman, Balmer, Fashion, Bracket, Fund. So Lyman series, if any excited electron is coming into the first energy level, if any higher energy electron is coming into the first energy level, that is the principal quantum number 1. So this type of the light fall into the ultraviolet region. If any electron is coming from the higher energy level to n is equal to 1, it is having the highest energy light, and it will be present in the ultraviolet region, and it is called a Lyman series. And when any higher energy electron is coming into the second level, that is the principal quantum number 2, this light is having the less energy compared to first one. The Lyman series energy is more, and Balmer series energy is less, and this light present in the visible region. That means if any electron is coming from the higher energy level to second energy level will fall in the visible region is called Balmer series. Similarly, if any higher energy electron is coming into the third energy level is called Fashion series, fourth energy level is called Bracket series, and fifth energy level is called Fund series. And these three energy levels are present in the infrared region. So these three types of the series energy level is, so energy of the light is very less compared to previous two, and these are present in the IR region. So like that, hydrogen spectra contain the total 5 different series in the 3 different regions. One series, that is the Lyman series, present in the UV region. Balmer series present in the visible region. Fashion, Bracket and Fund series are present in the IR region. So that means if any higher energy electron, the electron present in the second, third, fourth energy level is coming into the first energy level, that is called Lyman series, is present in the ultraviolet region. If any higher energy electron which is present in third, fourth, fifth is coming into the second energy level is called Balmer series, present in the visible region. So 4, 5, 6 electron if it is coming into the third is called Fashion series. 5, 6, 7 or higher energy electron is coming into the fourth one is called Bracket series. If excited electron is coming into the fifth energy level is called Fund series, and these three are present in the infrared region. And to calculate the wavelength of the light emitted by in this series, we are using the Rydberg equation. By using the Rydberg equation, you can find the, so what it may be, different type of the lights emitted in this series, you can find the wavelength. To find out the wavelength of the light, a Rydberg equation is proposed, that is called 1 by lambda is equal to RH into 1 by NF square minus 1 by NI square. So what is the NF, find NI here? NF is nothing but, so into which energy level electron is coming. For example, Lyman series, the NF value, or it is also called N1, 1, Balmer series, 2, Fashion series, 3, Bracket series, 4, Fund series, 5. Into which energy level the electron is coming, that is called NF value. And what is the NI value? From where electron is coming. In case of the Lyman series, the NI value may be 2, 3, 4, 5 up to infinity. In Balmer series, the NI value will be 3, 4, 5, 6 infinity. Fashion series 4, 5, 6. Bracket series 5, 6, 7. Fund series 6, 7, 8. Like that. So into the which energy level electron is coming, that is called NF value. From which energy level electron is coming, that is called NI value. So by substituting the NI and NF values in this equation, we will get the wavelength of the every light present in the hydrogen spectra. For example, let us come to Lyman spectra and Balmer spectra. So in the Lyman spectra, so what is the Lyman spectra? When any electron is coming from the higher energy level to first energy level. The electron may be coming from the second energy level, may be coming from the third energy level, it may be from the fourth energy, fifth, sixth, seventh, or like that. So if the electron is coming from the second energy level to first energy level, that is called alpha or H alpha. That is first line. What is the meaning of the first line? Second energy to first energy. If you are substituting the NF value is the 2 and NI value is 1, so that is called H alpha line. The H alpha line wavelength is 121.6 nanometers. Similarly, when electron is coming from the third energy level to first energy level, it is called H beta line. Its wavelength is 102.6. If the electron is coming from the fourth to first, the wavelength is 97.3. Here wavelength is gradually decreasing, means the energy of the light will be increases. The H alpha line energy is less, H beta line energy is little bit more. So like that, the energy of the light will be gradually increases. So these are the different lights or different wavelength lights present in the Lyman series. Similarly, let us come to Balmer series. So in the Balmer series, H alpha line is nothing but when electron is coming from third energy level to second energy level, its wavelength is 656.3. Similarly, H beta line, fourth energy level to what is that one? Second energy level, its intensity is 486. Fifth energy level to fourth energy level, its intensity is 434. And these are the different type of the lights present in the Balmer series having the different wavelengths. The first one is the 656.3, it is present in the red color. The second one is 486.1, it is present in the green color. Third one is 434.1 nanometers, it is present in the blue color. Fourth one is 410.2, it is present in the violet color. So these four are present in the visible region. And when you come to this energy level, which is coming from the seventh energy level to second energy level, it is having the higher energy than visible light. Only these four lights are falling into the visible light. One is the red color, one is the green color, blue color and violet color. So similarly, by substituting the NF and NI values in the fashion, bracket and fund series, you will get the different wavelength lights present in the fashion, bracket, fund also. For example, fashion series, substitute the NF value 3 and NI value 4 or 5 or 6, you will get the different lines present in the fashion series. Same thing in bracket, NF value 4 and NI value 5 or 6 or 7, you will get the different lines in the bracket series. Fund series also, substitute the NF value is 5 and NI value 6 or 7 or 8, and we will get the different lines in the fund series. And these three series lines are present in the infrared. Thank you.